In this lesson, we'll be talking about rational expressions. So, first off, a rational expression is the idea of having a polynomial over a polynomial. So, rational expressions, being a polynomial over a polynomial, do mean that there's a possibility of the denominator being 0. So if we look at this as p of x over q of x, anytime this denominator is 0, the expression is undefined. So, one of the things that we want to do is learn to watch out for when the denominator is 0, and that's anytime a polynomial is equal to 0. So we've worked with this a little bit in the past. One of the things that's nice about rational expressions is it's possible that you can factor and cancel out common factors. Now, one thing to be very specific about is you can only cancel when you have factored it and you're canceling factors. That's a very important thing, because cancellation is division. Like, for example, I've seen students will look up here and will just say, let me cancel the x squareds. No, just no. You have to factor it. After you factor it, then you can cancel your factors. So, if we factor it, this is what it would look like. You might have some expression times another one over some expression times one that's up top. Then if you just cancel out these two expressions, you're just left with a over b. But one thing is that this c that you originally had still cannot be 0. So we'll come up to this a little bit later, but for right now, let's do a basic example of just simplifying. So we'll start out by factoring this expression. So this one you can write as x minus 7 times x plus 4. Hopefully you guys are still decently good at these. And the denominator can be x plus 5 over x plus 4. So since these are factors, we may cancel out our factors, and we just get x minus 7 over x plus 5. And now here's where the rest of it comes in. So I ask you a quick question. What value of x would have made the denominator 0 for this x plus 4? So what value would have made x plus 4 equal to 0? The answer is negative 4. If you were to plug in negative 4 for x, this expression would be 0. Now it's gone. The negative 4 constraint is not here for this simplified expression, but because it used to be there, we still say x cannot be negative 4. So anytime you cancel out a factor, the value that would have made that factor 0 does need to be left as x cannot be that value, even though it doesn't appear in the final answer. Let's continue with more examples. So we might do a little bit of this off to the side, or maybe below will do. So for this one, we can start out by doing a factor by grouping approach for the numerator. So you'll notice I roped off the first two terms, and for the minus I wrote it as plus a negative, like we've done in the past. So now I can factor out an x squared, and I'm left with x plus 3. I can factor out a negative 4, and I'm left with x plus 3. So I get x squared minus 4 times x plus 3. And due to difference of squares, this part is x plus 2 times x minus 2, and the x plus 3 still remains. Alright, so let's do that up top. We have x plus 2 times x minus 2 times x plus 3. In the denominator, this one's much easier to do. This one is x minus 2 times x minus 5. So in this case, we can cancel the x minus 2's, and we get x plus 2 times x plus 3 over x minus 5. You can leave it factored, that's fine. But we need to point out x could not be, we look again at these values that I canceled out. what value of x would have made a 0 where the x minus 2 used to be? 2 is the right answer. If x were equal to 2, the denominator would be 0. So we say right now, x cannot be 2 in this final answer. Alright, let's continue. Now here, x cubed minus 8 is x cubed minus 2 cubed. That's a difference of cubes. So if you use the formula, which again I'll give these to you on a test, but remember to always have it available for quizzes. The formula is a minus b times a squared plus ab plus b squared. And so, in the numerator I get x minus 2 times x squared plus 2x plus 4. There's my difference of cubes formula. And then for this one, again, you're welcome to use whichever method works best for you, such as the AC method. I see I'm going to need to do -2, and I see the -5, so I'm thinking about the fact of 3 times 2 is 6, and that's pretty close to -5. So if I let this be -2, and this one be 1, that should do it. 3x squared minus 6x plus x is my minus 5x, and minus 2. Cool. So again, the x minus 2's cancel out, and I'm left with x squared plus 2x plus 4 over 3x plus 1. And remember, anytime you cancel something out, that value is no longer allowed. So, x minus 2 would give me, again, a 2. That's what would give you a 0 in the denominator. Alright, so let's continue. So, let's do some operations with these expressions next. Again, the idea is that all you really have to do is factor these things and cancel out any common factors from the numerator and denominator. What goes a little bit further in this problem is that since we have 2 factors that we're multiplying together, if we want to, we can take a factor from the left and a factor from the right and cancel them out, as long as there's still one on top and one in the bottom. You've probably used this technique before when you were just multiplying fractions in the past. So, let's start out by factoring each numerator and denominator. This might take a little bit of time. So, 2x squared plus x minus 6. Again, you're welcome to use the AC method here, but I'm going to use a little faster approach. In my technique, I look at 2 times -6, and I think -12. Alright, so what multiplies to -12 and adds to 1? Well, that's got to be 4 and -3. So I put in a 2 to get a 4 and a -3 to get what I need. And you'll notice that these multiply to -6 also. So that's the numerator. The denominator is easy. This is x plus 5 times x minus 1. And then for this expression, let's factor it off to the side for a moment. So I see that it's got an x cubed in it. That means I can factor out a x first off. So I get x squared minus 3x plus 2. And so that gives me x minus 2, x minus 1. Alright, let's copy that over here. X times x minus 2 times x minus 1. And then in the denominator, I can factor out a 2x, which gives me 2x minus 3. So now we've done all the factoring that we can, and let's just look for any expressions that are common to both a numerator and a denominator. The first one I see is 2x minus 3. And again, you are welcome to cancel as long as one is on top and one is on the bottom. I see x's that I can cancel out, and I also see x minus 1's. and I think that's everything I can take out. So now I just multiply straight across. I have x plus 2 times x minus 2 all over, note there's still a 2 here, don't lose that. I get 2 times x plus 5. Now, there's still some technical things of there's some values where this doesn't work anymore, but once we're starting to multiply these things, chances are we're not really paying that close of attention to where it's defined and where it's not anymore, so I'm just going to call this my answer. Next example. Now this one has division. So division is exactly the same way you do it with fractions. When you divide by a fraction, you instead multiply by its reciprocal. So let's start off by just rewriting the whole problem, but instead of doing division, I'm going to multiply by the reciprocal. X squared plus 2x plus 1 over x squared plus x plus 1. Now let's start the factoring process. So x cubed minus 1, this is a difference of cubes. If you want, you can call this x cubed minus 1 cubed. And so make sure again that you have this formula if you need it, but the formula is a minus b times a squared plus a times b plus b squared. The denominator is a difference of squares. This is a squared minus b squared. So we can get a plus b times a minus b. Alright, now, the numerator we can factor easily. I see this as x plus 1 times x plus 1. The denominator, though, if I'm going to find two numbers that multiply to 1 and add to 1, well, the numbers that multiply to 1, if I'm talking about integers, that's just 1 and 1. And those do not add to 1. So I don't think this can be factored. I'm just going to copy it as it is. So here's the good news. If you look at this one, this really is just x squared plus x plus 1. So I could cancel these two. And now we don't have to worry about the fact that that couldn't factor earlier. I see an x plus 1 that can cancel. And remember, you can always still take things from the same side and cancel them out. So I canceled out almost everything. All I'm left with is x plus 1. And that's fine as an answer. Yes, you could write a 1 on the bottom, but there's no reason to. Everything canceled out. Alright, so let's talk about addition and subtraction. Now there is a fast way. You probably have heard of the whole common denominator method, and you use that for fractions. But there's a fast shortcut that you can use, and by the way, this does work for numeric fractions. The way that I look at it is almost like cross multiplication. AD plus BC, and then in the denominator you get BD. So again, 1, 2, and then 3 for your denominator. It really is a lot like cross multiplication. And also, if this were a minus, I would instead get a minus on top. So let's use this technique to perform the subtraction of two rational expressions that have different denominators. So, again, I'm going to come diagonally first. So I get x times x plus 2. And then I keep this sign, that's a minus. And I'm going to multiply now the other diagonal. 1 times 2x minus 1. All over. Now I'm going to multiply the two terms from the denominator. 2x minus 1 times x plus 2. Let's simplify that a little bit. So I'm going to multiply x squared plus 2x minus 2x plus 1. And I'm not interested in doing the denominator. Let's just leave that factored. That might make our lives easier later. But let's see. It actually looks like we get some more cancellation. The 2x's cancel out, and so I get x squared plus 1 over 2x minus 1 times x plus 2. Now I don't see a way to factor this x squared plus 1 here. It's a sum of squares, and so we don't have a formula for that. So this is as simplified as it's going to get. If we want to take this concept a little bit further, we need to find the LCM. And so the LCM is kind of the same idea as you did with fractions, but we take this a little bit further when we're looking at LCM with algebraic expressions. So, if we need to add or subtract rational expressions that have a more complicated denominator, or perhaps if we're doing 3 or more, it's a good idea to calculate the LCM instead. So, here's how it works. First off, if there's any numbers, just find the common multiple for those numbers first. But for any expression, the least common multiple says look for any factor that appears in any of your terms. Write it down. So that's my first one. And if there's a power, we take the highest power for our LCM. This one has a power 1, and this one has a power 1, so I'll keep the power 1. Now let's look. Are there any more? Yeah. X plus 3. And there's a power 1 on that one also. So our LCM would just be x minus 1 times x plus 3. Let's do another. I see x minus 1 in this one. And x minus 1 appears in both raised to the 1 power. So we can just leave it as the 1 power. I won't write that this time. Next, I see an x minus 2. And that's only raised to the 1 power, so I'll leave it to the 1 power. I also see an x plus 3. So x plus 3, that's raised to the 1 power. I'll leave it the 1 power. Cool. Next example. X minus 1 again appears. And this time there is a power. I've got a choice between 1 and 2. Remember, anytime a power appears, pick the highest power. And then x plus 3 shows up. And that's raised to the 1 power, which I won't write. So this is how we calculate an LCM in this particular case. So let's use this idea to simplify a more complicated expression. So if I want to add or subtract rational expressions and I need to use the LCM, a really good idea is to start out by factoring as much as you can. And you might factor the numerators too, but I see this can't be done. X plus 5 is factored. 4, those are just numbers. But right here, x squared minus 4, that's a difference of squares. X squared minus 2 squared, so I get x plus 2 times x minus 2. And again, I still have the x plus 5 on top. And then I have 4 over x plus 2. So, what I want to do is I want to find the LCM of these 3 denominators. So let's see what that is. Well, I see I have an x that appears over here, and again, if there's an x, x is just hanging out by itself. The denominator does look at these as factors. So even though there's an x, but there's also an x plus 2, x stands on its own as an individual factor. There's only one x that shows up, so I'm just going to keep it as an x. Then we've got x plus 2. X plus 2 shows up in 2 of the terms, but the power that shows up is only 1, so I'll leave that. and then x minus 2 also shows up, again to the 1 power. So what I'm going to do here is I need to get every term to have this as their denominator. So what I'm going to do is I'm going to multiply in anything that is not part of the denominator currently. So 4 over x, that needs the x plus 2, x minus 2. And what I do to the bottom, I also have to do to the top. Alright. And then I've got the minus x plus 5 over x plus 2, x minus 2. Now this has almost all of it, it's just missing the x. So I'll put that in. And then we've got 4 over x plus 2. This one needs an x and an x minus 2. So let's take a look at this. If I just simplify what I have here, I end up with 4, and on top I'm going to go ahead and multiply this out. This was x squared minus 4 when we did it earlier, so let's just use that. And then I've got minus x times x plus 5, and then plus 4x times x minus 2. So you'll notice what I've done is I've just combined all of these expressions into the numerator, and in the denominator I get the common value of x times x plus 2 times x minus 2. Alright, so now let's just simplify this numerator. I get 4x squared minus 16 minus x squared minus 5x plus 4x squared minus 8x all over x times x plus 2 times x minus 2. So now let's just combine all of our like terms. I see a 4x squared and another 4x squared, which makes 8x squared, but then a minus x squared gives me 7x squared. I see a negative 5x and a negative 8x, so I get negative 13x. And then I have a minus 16. And so then we have x times x plus 2 times x minus 2 in the denominator. And we could simplify. If we could factor this, it might help, but this looks complicated enough that let's just leave it be and say that this is our final answer.